What's up, you freaking geniuses? So in this video, I'm going to teach you how to simplify complex expressions with large exponents, all right? So let's start with this one right here. So in parentheses, we have 3 plus 4i minus, in parentheses, 7 minus 5i plus 2i times, in parentheses again, 9 plus 12i. Okay, so the first thing you can do with some of these parentheses is actually drop them if they don't have a negative sign in front of them, all right? So 3 plus 4i, we can just drop the parentheses and write this as 3 plus 4i, okay? Now, for these sets of parentheses, you can see there's a negative sign in front of them, so we can't just drop them. The first thing we have to do is distribute this negative sign into these parentheses right here, okay? So if we do that, this first term, negative times positive 7, or negative 1 times positive 7 is negative 7, and then this negative sign times negative 5i is positive 5i, right? So plus 5i. Okay, and then the last thing we can do here is distribute this 2i into these sets of parentheses, so then that way we can drop those. So 2i times 9 is equal to 18i, right? So positive 18i, and then 2i times 12i is equal to positive 24i squared. Okay, now we can start combining like terms. So let's take care of just the numbers first. So 3 and negative 7, so that's equal to negative 4, right? And then here we have positive 4i, positive 5i, so that's 9i. So 9i plus 18i right here is 27i, right? So positive 27i. And then here we have positive 24i squared. Okay, now the nice thing here is this I squared, we can actually simplify this. So I squared is equal to negative 1, okay? The reason for that is because let's think of what I is equal to, right? So just I is equal to the square root of negative 1, right? That's the definition of I. So if we square this I, that means we're squaring this whole thing, right? And then when you square a square root, the square root or the radical and the squared exponent cancel out, and you're just left with whatever number's inside of here, which is a negative 1. Okay, so that's why I squared is equal to just negative 1. Okay, so we can replace this I squared right here with a negative 1. So we're going to say that we're going to have this positive 24, right, plus 24 times I squared, which again is negative 1. All right, so then simplifying this a little bit more, we're going to have negative 4 plus 27i, and then 24 times negative 1 is negative 24, right, negative 24. And then lastly, combining like terms, negative 4 minus 24 is equal to negative 28, right? So then our answer will be negative 28 plus 27i. Okay, and this is our answer in standard form. And standard form just means you want to write the number, the real number first, and then the imaginary number second. All right, so hopefully that wasn't too bad. Let's just try a couple more. Okay, so here we have a binomial times a binomial, so that means we're going to have to FOIL, right? So these parentheses, 3 plus 5i, times these parentheses, 2 minus 7i to the 4th, right? So if we're going to FOIL, let's see, the first term is going to be 3 times 2, which is equal to 6. The second term, or the outside, 3 times negative 7i to the 4th is negative 21i to the 4th. And then inside, 5i times 2 is positive 10i. And then lastly, we have 5i times negative 7i to the 4th, which is negative 35i to the 5th. All right, now let's simplify some of these imaginary numbers with these larger exponents. So first of all, we have I to the 4th, okay? So if you remember, I squared was equal to negative 1, right? And I to the 4th is the same thing as I squared times I squared, right? So then that means I to the 4th is equal to negative 1 times negative 1, right? And what is negative 1 times negative 1? That's positive 1, right? So that means I to the 4th is simply equal to positive 1. Okay, so then here we really have 21 times 1, which is just 21, right? So then here we can simplify this as 6 minus 21, right? And then here we have plus 10i, right? Plus 10i. And then here, negative 35i to the 5th. Okay, so now let's simplify I to the 5th. So I to the 5th, let's write it over here again. I to the 5th is the same thing as I to the 4th times I, right? And we already know what I to the 4th is equal to. It's equal to just 1. So here we really have that I to the fifth is equal to just 1 times I. And 1 times I is simply equal to I, right? So then I to the fifth is equal to just I, right? So this I to the fifth we can replace with just a single I, right? So then we're going to rewrite this as minus 35I. Okay, cool. Now we can combine like terms. So 6 minus 21, let's do this first, right? Since we want to write this in standard form. So 6 minus 21, that's equal to negative 15. And then here, 10I minus 35I is equal to negative 25I, right? So negative or minus 25I, right? So there's your answer for this one. All right, here's the last one. So in parentheses, 2 plus 4I to the fifth plus 1 minus 9I to the sixth minus 3 plus I to the seventh. Okay, so again, the first thing that we can do is drop the parentheses where there's no negative sign in front. So here we can drop these parentheses. So we could just say 2 plus 4I to the fifth. Here, there's no negative sign out in front of these parentheses, right? So we could just drop those also. So here we're going to say plus 1 minus 9I to the sixth. And then here we do have a negative sign, so we're going to distribute this in here. So here we're going to get minus 3 minus I to the seventh. Okay, now first let's combine some like terms so we can simplify this a little bit. So let's just do the numbers. So here we have a 2, a 1, and a negative 3. So 2 plus 1 is 3, and then 3 minus 3 is equal to 0, right? So these all just go away. So then we're just left with the imaginary numbers, 4I to the fifth minus 9I to the sixth minus I to the seventh. All right, so now let's simplify some of these imaginary numbers. So here we have I to the fifth. Now, if you remember from the last problem, I to the fifth was equal to just I, right? But let's just say we're starting from fresh, okay? So how would you figure out what I to the fifth is equal to? Okay, well, let's just go in order. So let's figure out what's I to the first power. Well, anything to the first power is just itself, so that's just equal to I, right? What's I to the second power? Well, that would be equal to the square root of negative 1 squared, right? Since we're squaring I, we know what I is equal to. I is equal to the square root of negative 1, but we're squaring it, so we're going to square it, okay? So then remember the square root and the squared exponent cancel out, so then we're just left with what's inside of this square root, which is just negative 1, right? So I squared is equal to negative 1. Okay, what's I cubed equal to? Well, it would be equal to, one way I could break it down is I squared times I, because I know what I squared is equal to, and I know what I is equal to, right? So then this would be equal to I squared, which again is equal to negative 1, times I, which is just itself, right? So negative 1 times I is equal to negative I, right? What's I to the fourth? Well, again, this would be equal to I squared times I squared, which is negative 1 times negative 1, which is just 1, right? So then what's I to the fifth equal to? Well, this would be equal to, I to the fourth times I, and I just figured out what I to the fourth is, right? It's 1, so this would be equal to 1 times I, which again is I. So just like in the last problem. Okay, and one last thing I want to point out here is that the pattern basically repeats, right? So I to the first was I, and then I squared is negative 1. And then I cubed is negative I, and then I to the fourth is 1. And then that pattern just repeats over and over again, okay? So here you can see, or here, I to the fifth, we just have an I, and we started with just an I, okay? So then that would mean I to the sixth would be the same thing as I squared, which would just be equal to negative 1, right? I to the seventh would be equal to negative I to the eighth is equal to positive 1, okay? So this pattern just keeps repeating. And the only difference is the sign flips. So starting with I to the first, you'll see we have positive I, we'll skip 1. We'll go to negative I, we'll skip 1. Positive I, we'll skip 1. We'll go to negative I, right? Same thing when we start from I squared, we'll have negative 1, we'll skip 1. We get positive 1, right? Negative 1, positive 1, and it just keeps going like that. Okay, but in any case, now we know enough to finish this problem. So again, I to the fifth is this one right here, so it's equal to just I, right? So we're going to replace this with just an I. So here we're going to have 4I minus 9 times I to the sixth. What's I to the sixth? I to the sixth is right here, negative 1. So we're going to plug in the negative 1 for I to the sixth right there. and then minus I to the 7th. What's I to the 7th? I to the 7th is right here, -1, or sorry, -I. So we're going to plug in a -I right there. Okay, so then we get 4I plus 9 plus I. Okay, and then writing this in standard form, again, our number goes first, right? So we're going to say 9 plus 4I, and I is 5I, right? So 5I like that. So 9 plus 5I. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.